Hey everyone, it's Mr. Canfield. Today we already got a problem. Let's see. All right, I moved my super impressive rig. Do a little more. There we go. We're gonna start over. Hey everyone, it's Mr. Canfield. I'm not gonna edit this though. So today we are going to be learning about what are called literal equations and formulas. Remember, we're taking notes and you're going to turn in your notes, so make sure that you take good notes as we go through. If you're not writing something down, why not? It better be, because you already get it perfectly and you're going to get 100 on a test perfectly. So all right, so what the heck is a literal equation? Well, the word formula might actually give you a hint about that, but here we go. So as always, I've got things kind of written up for us already, and we're just going to go through and take care of it. So here's our first example. It says, write an equation to represent the perimeter of this rectangle. So what I would do is I would pause the video and I would take down example 1. These are L's and those are W's. I tried to use cursive L's and it didn't work super well, but that's what that is. And we've got a couple questions at the bottom too, but at least write this part down. All right, so if you haven't paused and done that already, I'd pause because I'm moving on. So perimeter. Well, what does the word perimeter mean? So the word perimeter means the distance around something. So distance around. So if you didn't know that, I'd write that down. The perimeter is distance around something. So, well, if I look here, I could say, well, it's this, and then this, and then this, and then this. So I could say perimeter is equal to this plus this plus this plus this, right? Like, so if you thought that's what perimeter was, you're exactly right. But that's kind of a silly way to write that. Instead of saying add the width plus the length plus the width plus the length, it's a rectangle. So we know those two widths are the same. So instead we could say, well, like, we can combine like terms, right? I have one W and another W. That's 2W when we add them. And then 2L as well. This might be a familiar formula. You might be used to seeing it as equals P over here. But yeah, 2 times the length, or 2 times the width plus 2 times the length. What about area? So area, you might remember from before, area is length times width. So we could just say area is equal to LW. So these are both examples of what we would call literal equations. Literal equations have multiple variables that represent different amounts, that represent different things. So like here we have a variable for width, a variable for length, and a variable for perimeter. And all 3 of these things vary, which is what the word variable means. So a normal equation would be like 3x minus 5 is equal to 12. Oops. Because there is only one variable. Sometimes we'll have an x and we'll have a y. We don't call those literal equations either. But literal equations, that's when we have multiple things. Yeah, here's some other literal equation with multiple variables standing for different things. A lot of times doing with things in the literal world, the real world. All right, so this is still part of number 1. I just ran out of space on my previous paper. If W is equal to 3 and A, good job. Okay, So you may notice there were some typos on here. If W equals 3 and P equals 36, not A, what is L? So if W is 3, P is 36, what's L? So that's a situation where we can actually substitute 2W. Wait, what's between the 2 and the W? There's nothing written there. Like there's a plus written here, but there's nothing written here. Well, it's because that's actually times. So anywhere I see a W in here, I can put a 3. We don't know L, so I can leave that alone. And it says P is 36. So instead of writing a P, I can write 36. So if I simplify this, let's see, 2 times 3 is 6. Wait a minute. This is just an equation. That 2L, that's like 2x. So I could solve this using traditional solving moves, just like we've done before. Or I could push the paper off the screen and be very confusing. So, if we put our wall in, and remember the wall is optional, you do not need to draw the wall. Well, we just use our solving moves. So our first solving move is we take any x's or y's and we move them away. Sorry. What am I thinking of? We do any pluses or minuses, right? So to get the 2L by itself. So I see this is a positive 6, so I'm going to subtract 6 from both sides of our equation. So now they cancel. Over here we have our 2L, and over here 36 minus 6 gets us 30. And then we can divide both sides by 2 and get L is equal to 15. Remember, when it's a number and the letter and that's all that's left, that's when we're allowed to divide. I can't divide here because I still have this other stuff over here. I have this 6. You can only divide like that when it's by itself. And that's like in order to keep you from making mistakes. There is actually a way to do it up here, but it brings some other stuff in that I'm not talking about. So it's more complicated, and there is a way to do it, but I'm not showing you right now. So that means that L is 15. Something helpful to do when we're doing math is to circle our answer or box our answer. Something else you might notice is that every time I write an equal sign, I try to write it underneath the previous one. And so stuff on either side gets messed around, but if the equal sign is lined up, it's super, super easy to follow the work. And I don't just do this in your class. I was filming a video for one of my calculus classes earlier. Here's some spooky looking stuff. But all I want you to focus on is see how those equal signs are lined up? Nice and straightforward. No matter what's going on, that equal sign helps you know where the next step is. All right. Let's see what comes next. Are we on example 2 yet? Oh no, we're not on example 2. Okay, so here's the deal. I could pick things for W and P all day and get different things. But the thing is, every single time I do it, what's gonna happen is I'm gonna get this number, I'm gonna move it over here, and then I'm gonna divide by 2. It doesn't matter what these are. Like if W was, here, let's just improvise. Let's say if W was, here, pick a number. No, really, pick a number. I'm going to pretend you picked 10. And then I'm going to pretend that for P you picked 80. So if we go into, if you picked either of those numbers, spooky, right? Yeah, you probably didn't though. So if I do this again, it's literally the same process. So the W is going to be 10 again. So here we get 20, because 2 times 10 is 20. Then we'll subtract the 20 from both sides. I'm going quickly through this because I wouldn't, like I'm not expecting you to actually do this work. I want you to see that it's exactly the same thing. So then 80 minus 20 gets us 60. Then we divide by 2, we get L is equal to 30. So the first thing we did was 2 times 3 or 2 times 10, we got that number. Then we subtracted that number. And then we divided by that too. And since we do that every single time, there's actually a way to do this without plugging in different numbers every single time. And this is where literal equations are very, very useful. Instead of Canfield, why'd you gotta go and do that? You've been writing 2w plus 2l. I'm gonna keep on writing 2w plus 2l. Silly Canfield. What I'm gonna do is I'm actually gonna solve for L without plugging in any of the numbers. When I knew W and I knew P, let's talk about what we did first. Well, we found out what 2 times W was. I don't know what number that is right now, so I'm just gonna leave that, but I'm gonna understand that this is gonna be some kind of number. We don't know what number it is, but it's gonna be some kind of number. And how did we get that number away from this 2L? Well, we subtracted it. So we can actually subtract, it's weird, but we can subtract 2W from both sides. And whatever it was, it's going to cancel with itself. Oh, I forgot to put the wall in. There's definitely some joke about Donald Trump and walls and stuff like that, but like, I can't think of one that's not like political. Like, you definitely could make some kind of political joke, and I'm not trying to say he's good or he's bad. Like, you're welcome to your own political views on him. But now that I keep on calling this a wall, I can't help but think about all the controversy with the wall. Anyway, we have this 2L. Here's the problem. P's some number. 2W is some number, but I don't know what they are. I don't know what either number these are. I do know that whatever it is, it's going to be P minus 2W. They're not like terms, so I can't combine them. But I can say, hey, whatever P was minus 2W, that's going to be our number. And so, if you're thinking closely about this, what we were doing here, we did P minus the 2W, and we just got some number. And I wrote it in blue. I'll write it in blue again. So 36 minus 6 was 30. P minus 2W is, I don't know, but I could write, it's going to be this number. I'm going to plug stuff in. I'll get some number there, right? That's going to be a number all on its own. And how did I get L by itself after that? Well, after that, we just said we'll divide by 2. And I'm going to take this number and divide by 2, right? So it's the whole number. So I'm going to divide the whole number by 2. And so we can say L is equal to, it looks really funky. Let's say P minus 2W all over 2. And you might be like, that's really terrible looking. And at first glance, it kind of is. But let's go back and let's talk about this really quick. If W equals 3 and P equals 36, these are the same numbers we had earlier. Let's look at what happens here. P was 36, right? So 36 minus 2 parentheses all over 2. Okay, keep going. Well, W, that was W, right? W is 3. So check this out. 36 minus, 2 times 3 is 6 all over 2. If I'm following the order of operations, I do the top first and the bottom, like I clean up the top and bottom separately. So 36 minus 6 is 30. The bottom is 2. 30 divided by 2 is 15. So we got the exact same answer as we did before. And you might be like, yeah, but that was awful. Here's the thing. Let's say I needed to use this over and over and over again. And I kept on knowing W's and P's. Like, okay, W is 3, P is 36. Let's say W equals 10, P equals 80. Well, then I just plug those two numbers in. Boom, boom, done. Then let's say W is equal to your face, and P is equal to an alien's face with 3 eyes. Then we just drop them in. Like, it doesn't matter what numbers they are. That's what I'm trying to say. It could be something silly. These aren't numbers, though. Your face is not a number. So I could plug in a whole bunch of things and get it to do it all at once. So that's why we learn about literal equations. The big reason we learn about literal equations is they help us do science, in all honesty. A lot of times what will happen is we'll have this idea in science, we'll understand how two things are related, and you know what, let's just do science. We're gonna do some science. And we're gonna talk about Sarah. Sarah's from our textbook, so these examples are from our textbook. Oop, I need to move down. All right, I know all that was example 1. Don't worry, like, look at how long the video is. This isn't going to be a 12-hour video or anything. So, example 2. In a half hour, Sarah is meeting her friends at the lake, 6 miles from her house. You know, commas mean pause, not stop completely. Can't feel. Let me try to read that again. In a half hour, Sarah is meeting her friends at the lake. I did it again. In a half hour, Sarah is meeting her friends at the lake 6 miles from her house. There we go. At what average speed must she ride her bike to get there on time? And so we're going to use a classic equation. Distance is equal to rate times time. If you did not know this, this is a scientific fact that it's a fact of our universe. If we want to know how far we went, we take the speed that we're going and we multiply that by how long we were going it. So, for example, here's a little sidebar for you. Let's say I'm going 100. Right, I should have written in red, right? 100 miles per hour. If I'm going 100 miles per hour for 2 hours, well, how far did I go? A lot of us can kind of just think about this and go, oh, you went 200 miles. Let's say that wasn't as obvious to you. If I want to know how far I went, I know that my total distance is equal to my rate. My rate was 100, and my time was 2 hours. 100 times 2 is 200. So it becomes more helpful when we have things like you were going 37 miles per hour for 53 minutes. Now, since this was in hours, I would need to convert this into hours. But it helps us get numbers in cases where it's not as simple with like 102. I picked easy numbers for that one. And in science class, you do a lot of things where you learn how to manipulate the numbers and stuff. That's actually a big reason why we learn this and why we do algebra, so that we can manipulate science. So this one says the lake is 6 miles away. So 6 miles away, is that our distance? Is that our rate? Or is that our time? So the only word here that I would expect you struggle with would be rate. Rates are things like speeds. They're things like how much does it cost each hour. They're things that recur, like your monthly bills. Things that happen over and over again. That's a rate. Distance is just how far, and then time is time. So it says at what average speed? Average speed, that is what we would call a rate. So we just learned that we don't know R. Let's see. We also learned 6 miles from her house. So 6 miles away. 6 miles away, that's going to be a distance. And then I don't see a third number. I don't see any other numbers. It's because it's hiding in the English. I actually need to get another marker. I want another color. I am going to get this one again. In a half hour. That is time. So we like to give our speed in miles per hour. How many hours is a half hour? It's not 1 hour, it's 0.5 hours. Or you could even just use the fraction 1/2. So I could say this is rate times 0.5. So if I want to know the average speed she needs to go, all I need to do is solve this and get the rate by itself. So rate is equal to, let me drop the wall in there. So I'll divide by this number, 0.5, and then divide by 0.5. Now 6 divided by 0.5 is a little counterintuitive. Dividing by decimals smaller than 1 usually doesn't work the way that we think it's going to. And this is no different. So 6 divided by 0.5, if you haven't already tried it, 6 divided by 0.5 is 12. And so she needs to go at 12 miles per hour. Really quick, I want to show how you would do this in our calculator. So I don't have a physical one with me. I have to go back to school and get them. But I do have the one on my computer screen. So it's a little janky, I know, but here's my computer screen. So let's say you just have your computer screen. If you go in to your apps, you should see, I've got it here, TI-84 plus CE. So it's this nice looking calculator. I'm gonna hit the clear button. And I wanted to do 6 divided by 0.5. So that got me 12, but let's say I wanted to do 6 divided by 1/2. 6 divided by 1/2. This does not work. And it's because the calculator doesn't understand that I want to do 6 divided by 1/2. What the calculator just did is the calculator did 6 divided by 1, get an answer, and then divide by 2. I'm like, no, I want you to do 6 divided by parentheses 1/2. So doing that will work. Some calculators actually have a fraction button, and that's awesome. Ours has a way to turn things into fractions. So like, let's say we have 99 divided by 15. Oh, I got 6.6. There's a way to turn this answer into a fraction. So check this out. If I go over here to math and click the math button, that first answer, arrow frac, if I click enter on that, it says ANS, which means the answer it just got, to frac. It will simplify your fraction for you. That's right. The calculator that we have access to simplifies fractions for you. So if I have something like, I'm just going to type some random numbers. Bleh. I can then go math and see if it simplifies at all. Oh, I picked numbers that were too big. If you pick numbers that are too big, I think it's over 10,000. Yeah, so I think 4-digit numbers and smaller it can do. So it just simplified that nasty fraction for us. So again, you click the math button and that very first option. You can even press the menu item that it is. So it's number 1, I can press 1 and then it'll do it. All right, anyway, back to the topic at hand. I like showing you guys tricks that our calculators can do. All right, let's see what's next. All right, we've got a picture here. Perimeter is 144. The length is 40. How wide is the frame? So knowing that perimeter is 2W plus 2L, we can just drop the numbers in like we normally do. Or we could solve for W first and then plug the numbers in. It's up to you, and I'm not going to tell you which one you need to do. But if you haven't already, try it yourself. I'm going to pause for just a second, and then I'm going to write down what I got for my answer. All right, so personally, I think solving this for W first is actually more work than I want to do. I'm going to say 2W plus 80, right, because 40 times 2 is 144. I'll subtract the 80 from both sides. 2W is equal to, what is that, 64? Divide by 2, divide by 2. 64 divided by 2 is 32. So I got that the width is 32, and we could solve this for W. We've basically done one just like that. I wanted to spend a little bit of time on this next equation. We just got a couple more things to talk about, but this is a big one. This is another real life equation. It says C is equal to 5/9 F minus 32. I'm actually in class right now while students are taking a test, so I just need to pull up the chat to make sure nobody had any questions. I've also got my headphone in just in case they need me. Okay. So this is a conversion from, if I know my degrees Fahrenheit, I want to convert to degrees Celsius. So here's a couple examples just to make sure you understand how this works. So I would try this first one. You might even know the answer. If it's 212 degrees Fahrenheit, what is that in degrees Celsius? You might recognize 212 degrees Fahrenheit as the boiling point of water. Water. So if I go in, oh no, wrong color. Meant to get a blue. This isn't just regular blue though, it's Blue Lagoon. All right, so if I look at this, well, 212 minus 32, I'm actually going to use my calculator for this. This number is kind of big. 212 minus 32, I got 180. So, you know, it's honestly worth showing you guys. If I want to do 5/9 times 180 in my calculator, then we'll take our calculator, and we want to be careful. 5/9 is a fraction, right? You always want to put a fraction in parentheses. 5/9, like that. So if I'm doing 5/9 times 180, I can do that. 100. So in case you did not know, 212 degrees Fahrenheit is 100 degrees Celsius. What about 32 degrees Fahrenheit? Do you know what that is? That's freezing. Do you know what freezing is in Celsius? Let's see what happens when we do the formula. So where F was, we'll put our 32 minus 32. So the reason I did 212 minus 32 first was we got to do, please excuse my dear Aunt Sally, right? We got to do parentheses stuff first. So 32 minus 32, wait, that's 0. I'm not going to go to my calculator for this. Do you know what 5/9 or anything times 0 is? 0. And I'll leave this one to you. What about negative 41 degrees Fahrenheit? This is one of my absolute favorite temperatures. And if you're not sure why, use the formula and see what happens. This is a fun one. So pause the video, try this one. It's the exact same number. Now I'm like, wait, is it? Or is my memory off? Hold on, negative 41 minus 32. Whoops. It's not. I think it, oh, is it negative 40? I think it's negative 40. Let's do negative 40. Oh, I'm glad I actually checked this. Whoops-a-daisy. I was off by 1. So negative 40 degrees Fahrenheit is negative 40 degrees Celsius. That's weird, but it's true. So they have different boiling points, different freezing points, but then negative 40 degrees is the same for both. Sorry if I scared you with the 41. I made a mistake. So let's talk about how we would actually take this and solve it for f, so that instead of saying c is equal to a bunch of stuff with f, we'll be able to say f is equal to a bunch of stuff with c. We'll be able to do reverse stuff. So we've got to talk about how we clear fractions out of an equation. So we have this block of parentheses, and we're not really concerned with that. It's 5/9 times that block. So a way that we clear out fractions is we multiply both sides by the denominator of those fractions. So I'm going to take this side of the equation, and I'm going to multiply it by the bottom, which is 9. Now, whatever I do to one side of the equation, I have to do to the other. So I'm going to multiply this side by 9 as well. So now I have 9c is equal to 9 times 5/9 becomes 5. If you don't believe me, try it out. Just do 9 times 5/9. So if I'm trying to get f by it, oops-a-daisy, that's an f. If I'm trying to get f by itself, well, now I need to think about solving this equation for f over here. So I'll take 5 and distribute it and get 5f minus 32 times 5. Let's see, that's 160. So I have 9c is equal to 5f minus 160. So if I want to get f by itself, I'll have to first add the 160. Remember, we always do adding and subtracting first before we do any multiplication or division. So now I have 9c plus 160 is equal to 5f. And then, to get f by itself, we'll just divide both sides by 5. Now, since I've got this whole mess here, I do have to divide this whole mess here. And earlier I talked about there's a way to divide when there's multiple things. We actually are just going to distribute this division. So 9c we're going to divide by 5, and this 160 we're going to divide by 5. So we're going to divide them by 5 separately. So 160 divided by 5 is just going to give us 32. And 9c over 5 I could rewrite as 9 over 5c. And so you might notice there's a similarity here from one to the other. So it's kind of interesting. If you didn't follow everything there, that's okay. Key things to make sure you understand is that if I have something like 9c equals 5f minus 160, we have to be able to add and solve from there, just like we did before. And you also have to know how to distribute. That first clearing the fraction step, if that tripped you up, we don't do that a ton, but it is a trick that we can use. All right, I think there's one more example. I have my Xbox One S here. Totally an Xbox and not just some random box that I drew an X on. The volume of a box is length times width times height. So we could call this the length over here, we could call this the width here, we could call this the height. That's the volume of a box. If we wanted to take this and solve this for L, meaning get L by itself, the problem is this says L times W times H. Well, let's think about an aside really quick. Let's say we have 100 is equal to 2 times x times 5. How would you find out what x is? Well, we could divide both sides by 2, right? 100 divided by 2 is 50. And then to get rid of that x times 5, we could divide both sides by 5. 50 divided by 5 is 10. Let's see if this makes sense. 2 times 10 times 5. All right, I just substituted it in. 2 times 10 is 20 times 5. Yep, that's 100. So that worked. We were allowed to divide and then divide. What happens instead? Let's pick the exact same thing. We know the answer already, right? 100 is equal to 2 times x times 5. What if instead I divided by 2 times 5? Wait, what's 2 times 5? It's 10, right? What if I divide by 10? Divide by 10. Sure enough, the 2 and the 5 and the 10 over here, they're all going to cancel, and we're left with 10. So something we're allowed to do is if there's a string of multiplication, I actually can divide by multiple pieces of it all at once. So if I want to get L by itself, it says solve for L, right? That means get L by itself. That's one way to say it. The math word for get it by itself is more criminal sounding. Isolate that criminal. So we just divide both sides by W and H at the same time. So we can say L is equal to V over WH. And that's all we can do with that. We can't do any more. We don't know any of the numbers. But if we know the volume, we know the width, and we know the height, we can do this formula and get L. So that is literal equations in a nutshell. Hopefully this video was helpful. Sorry again about the 41, and sorry about my stupid jokes. There will be many, many more of them. But now you should have enough to go off of to do your homework assignment. So you know where to find me if you have any questions. Bye.